Push That Rock here with Simpson Math. I want to talk a little bit more about visualization in math. So mathematicians like to try to visualize problems or concepts. For instance, if we're multiplying 7 by 11 by 13, we like to visualize that. If it's a product of three numbers, you can visualize it as a volume. So here we have a rectangular prism, and it's 7 by 11 by 13. And we like to visualize it as such. Here's another example. Say we have the area of a circle. Well, we all learned in grade school that the area of a circle is pi r squared. But how do we visualize that in mathematics? Well, we look at the radius. Here's the radius. This is also the radius. So they form a square. So color that in. And when mathematicians say pi times r squared, they say, oh, that's about 3 r squareds. So about 3 of these will fill up the circle. It actually, since pi is a little bit bigger than 3, it takes a little bit more than 3 of these squares to fill up that circle. Obviously, 4 would be too many, right? If I put 4 in, I'd be way too big. So it turns out you need about 3 of them. And that's how we like to, in math, we like to visualize it. So let's talk about one of the most famous theorems in mathematics. Y'all may know the Pythagorean Theorem. In fact, you're going to need it for one of your tasks this week. The Pythagorean Theorem says that a leg squared in a right triangle, a leg squared plus a leg squared is equal to the hypotenuse squared. So if we label this distance over A and this distance up B, so this height is B here, going up is B and going over is A, then this length here is A and this length is B. And the Pythagorean theorem says A squared, this distance squared, plus B squared, this distance squared, has to equal the square of the hypotenuse. So this distance across here squared. Well, mathematicians like to visualize squares as squares. So here's A squared, A by A space right there. Here's a B by B area right here. And then here's a C by C area right here. And the theorem is saying this squared put together with this squared will equal exactly this area in here squared. That's what the theorem's saying. And there are many, many ways to prove this theorem. But for your task, you just need to rely on this theorem, but use the visualization tool of the XY plane, the Cartesian plane. Use that tool to help you out. Math Made Simple at Simpson Math.